G'day, my name is Gregg. Welcome to the eBPF Summit 2021, and I'm joining from Sydney, Australia. In this keynote, I'll share how to get started finding performance wins using eBPF. I shared a similar keynote for the first eBPF Summit, but eBPF is a changing and evolving space, so it's important for me to share updates. Now, for a lot of other technologies, if you want to get started, you can do an internet search and click on the first how-to guide. But because eBPF has been changing, an internet search will uncover many documents that used to be true back in 2015, but are no longer so true today. Many of these documents get you to start by programming BPF, using the Python BCC interface, for example. But that's not really how we want you to get started today for performance wins. I've decorated this screenshot with the first article is not for beginners, the third article is not the best start, and so on. Also, if you do a search for BPF, you'll find many explanations of the acronym that are also dated. So nowadays, BPF is a technology name and no longer an acronym. BPF itself is a bytecode and execution environment that we're using to create observability, networking, security, and other software. So how do you get quick and easy BPF performance wins? It's to think like a sysadmin and not like a programmer. I used to be a system administrator at the start of my career, and my job was to make sure that all the required software was installed in our systems and worked. And nowadays, there are two great collections of BPF performance tools you can install. There's BCC and BPF Trace. And so you can install them and immediately start using that software and get performance wins without having to start by writing code. Those are the commands on the slide, and I've highlighted the top 5 commands you can try. And you'll find these are quite useful. You might unearth some performance wins just from this one slide. So the first command, exec snoop, that's going to show you which processes are running or firing. And you might discover you have some background shell script that's calling things and perturbing your application that you've forgotten about, or something's launching out of crontab. The second command, OpenSnoop, that's great for debugging misconfigurations, like when an application is trying to read a log file that's missing or configuration file that's missing. TCP Live is great for seeing the flows of TCP connections around your environment. And so it will show the bytes transferred and durations and the IP addresses and so on. You might discover some unexpected TCP sessions or misconfigurations there as well. ext4 slower shows file system performance, and that's a more direct measure of performance than looking at disk metrics. And so straight away you may be able to eliminate the I/O stack by looking at how the file system is returning I/O and the latency there. And then to drill down into the I/O stack, BioSnoop shows you the disk access pattern, and you might discover issues there as well, such as outliers. So that's just 5 tools. You can just run them as is, and you might find some performance wins straight away. I'll share a case study of how these fit together, and this is from something I analyzed. This was a Cassandra database, and I begin by using the standard Linux tools like IOStat, and I saw that the disk utilization was around 15%. So this is a light workload, and I've got around 5 milliseconds for the average wait time. It doesn't look like a disk issue, but I know that averages, such as what these metrics and also what monitoring UIs show you, can be misleading. So before I rule out disks, I'd like to see a bit more information, and there's canned tools for that like BioSnoop. So I run BioSnoop, and wow, Perl is doing all this disk I/O. So Cassandra is a Java application, it's not a Perl application. So something is amiss. Actually, if you think about it at Netflix, if you find a Perl program going amiss, there's a good chance that I wrote it, since I love Perl. But there's only a few of us at Netflix who do and write software in it. So there's a good chance this is one of my own programs that's misbehaving. So what is it? Back to Unix tools, ps-ef, pipe grep Perl, and I see it's our log rotation service. And there should only be one copy of those. It has gone haywire and it's launched a dozen of them. And so that's an issue. And so we can fix it. And the Perl programs themselves were going haywire with this log rotation and ultimately causing disk I/O that was perturbing the Cassandra database. So, quick and easy performance win, and it's just including one of these new tools as part of your regular diagnosis toolset. IOStat, BioSnoop, PS-EF, and so on. And there's many other tools for getting more information from the system. Here's a diagram I've drawn of them where I've shown a generic kernel and operating system. And in black, a lot of the tools that come from BCC. And so you can apt-get install the BCC tools. In red are new tools I've been developing for my BPF book. And they're all open source. They're written using BPF trace. And my goal when I create a lot of these tools is so that you can solve more than 90% of performance issues using the canned observability tools, the tracing tools. If you need to write custom tools, you can do that too. When we talk about why BPF observability is awesome, this is why BPF observability is awesome. It's because all of these tools were created out of necessity, and they show metrics and insight that you can't get from the other tools. So BPF observability, it's not about coding this and that in the virtual machine. It's about this. It's about solving actual issues for your company. So whenever some people talk to me about why BPF observability, why should we care, it comes back to this diagram. It's so important. I put it on the cover of my book because this is why it matters. I also printed out and used to have it on my office wall. I've since moved offices. I need to put up a new one. And I use it as a checklist. You can, if you know you've got an issue, say in the block devices or disks, you can then go around and see which of those tools, canned tools, exist and see what sort of insights they provide. I can look at the SCSI level latencies. I can look at disk errors. I can look at the patterns of access and so on. And also, you can walk up the stack. In this case, the IO stack has the application system calls, VFS file systems, volume manager, and so on. I can walk up the stack and try all of these tools to really understand the performance of that IO from different layers. Now, that's great that we have all these tools and we can run them, but I think the future of BPF performance observability is really GUIs. At Netflix, we have hundreds of thousands of instances, and it's not easy to just log into a whole heap of them and try to debug performance. Which one do I log into? And if I pick one, then am I sure I'm on the right one that's causing outliers, or did I miss it? It's critical that we have user interfaces or GUIs that scale so that we can look at the cloud as a whole or applications as a whole. And ultimately, it will be the same with the new BPF observability sources that we've created. You will have a user interface, a GUI on top of it. Susie at Netflix has been creating one so we can click on CPU report and then it runs the CPU tools. So you get all that extra information you don't normally get out of monitoring. And there's different reports for different types of resources. It's using the open source tool, so it's built right on top of those BCC tools and BPF trace tools. And so as they get updated, we're getting the latest metrics. How do you fit this together? I've got an example diagram. So this is how we used to build it at Netflix. This is Netflix Vector, which we've now retired. But we had a web server that had the GUI web page, which is the dashboard interface. The client would load it, and then it would connect to instance agents, and we were using Performance Copilot, PCP, and those instant agents would launch BCC tools and then send the data back to the client GUI. And so that worked. It meant installing BCC on all of the servers. We're now doing a new one called Flame Commander. It's part of Flame Commander. Flame Commander does a bunch of things, cloud-wide profiling as well, and differentials. This one, the web server itself has the BPF trace tools, and then they get pushed out to the servers to run them. And that's great because we can update the BPF trace tools and customize them in one place, and then push them out and everyone's running the latest. Note that I don't have persistence in here. You can add a service so that you record data over the time. So this is just a simple model so that you can look at live metrics. So think like a sysadmin. Start by trying out these BCC and BPF trace tools and use them as is, fetch updates. If you look at them, some of them look deceptively simple. They may only be 100 lines of code. And I know sometimes when people get started with building upon BPF observability, they look at the tools and think, well, I'm just going to rewrite these in my own language. I would try not to do that because there are frequent updates. And it's because these are not the same as other types of software. A lot of these tools are instrumenting kernel, application, and library internals using dynamic instrumentation, which instruments the raw code. And that can change between versions. And so many of these tools require ongoing maintenance to match kernel changes. And so you don't want to inherit that burden. If you rewrite these tools, which you can do, you will then have the burden of having to update them all the time. If you can, try to use the upstream versions like we're doing at Netflix. And those upstream versions, the BCC and BPF trace tools, they are updated by the BPF engineers at Netflix, Facebook, Isovalent, and many more. So they're really the best. They're the standard tools. Now, sysadmins do sometimes program, and that will be the case here as well. So if you think about shell scripting awk and sed one-liners, how that looks for performance observability is BPF trace tools and BPF trace one-liners. So you will think like a programmer if you have a real-world problem that the tools don't solve. So you've tried the CAN tools, you need to go deeper into some weird part of an application or library or kernel, you can create a new tool. BPF trace is a great way to start. If you're a BPF-based startup, you may have greater needs of BPF and you want to go into programming. If you're debugging your own code, you need custom things. Or you're doing networking and security. Things that aren't performance observability don't necessarily have all the CAN tools. So, I mean, there are things out there for containers and other things as well. Or if you really want to learn BPF internals. So there are reasons to think like a programmer. But if it's performance observability, start with the CAN tools and see how far you get. The recommended tracing front ends, just to run some tools, BCC and BPF trace. If you want to hack up some new tools, BPF trace, it's like awk. It's very simple, it's easy to pick up. And if you want to spend weeks developing a BPF product, then BCC libbpfc, that's the new interface we're using. It's lightweight, it has compile once run everywhere, and the BPF type format base kernel information. BCC Python interface is now becoming the obsolete interface. It requires LLVM. It's special use only these days. But there's also GoBPF and the libbpf RS Rust wrappers. If it seems like there's too many front ends, it's similar with Unix. So if you want to run some tools, there's a lot of CAN tools in user bin. If you want to hack up some new tools, that's shell scripting, bash or awk. And if you want to develop products, then you'll be doing C and C++. As an example of BPF trace, I've mentioned it. Here's a tool that I wanted to write for a long time, read ahead, and it shows the read ahead. This is for the file system read ahead, and is read ahead working or not? This is something I wanted to answer. So what I'm doing is I'm showing if we read information or if we read data from files, how soon did we use it? If we used it pretty soon, it meant read ahead was doing what it's supposed to do. If it sat in the cache for seconds or minutes before it was used, read ahead may be too aggressive and need to be tuned. So this is great that I can just come up with this new tool and see the information I want to understand read ahead tuning. And what's great about BPF trace is the entire tool fits on one slide. Now I mentioned libbpf as well, so that's a new interface in BCC, and so it's using the latest core and BTF. With it, you can write tools that have the BPF code embedded in them, and so they do not require heavyweight LLVM or Clang dependencies. This makes them great for, say, embedded environments or space-constrained environments. And also in the future, we'll be able to just have a package of these lightweight tools, like 100 kilobyte tools that are completely standalone that you install, and then you get OpenSnoop and TCP Life and whatnot. Just as an important announcement, make sure to support the future of BPF, you have the config debug info BTF is set, and so lots of distros are now setting that. So the future for BPF in general is these event-based applications where you have user mode applications and then kernel mode applications where an event triggers them and they're running in that BPF virtual machine or sandbox environment. And it's really a new type of software. And I've drawn this table to show you the differences between BPF and user and kernel. And we have some of the best of both world attributes. So with BPF, it can be user-defined. So at the shell, I can create new BPF programs and run them, whereas at the kernel, it's much more complicated. But with BPF, I also get better device access. Not as good as the kernel, not completely direct, but I have these restricted helpers that run in kernel space, so I have much faster access to devices. So I can write high-performance software. And there are various other advantages over kernel software as well. So the takeaway, to get started with BPF performance wins, think like a sysadmin, install BCC and the BPF trace tools, run them, get some wins, then later on try programming if you like, but get some wins first, save your company millions, and everyone will love eBPF. I have some references in the slide, and I cover BPF in my last 2 books. And thank you very much. And thanks everyone for building BPF and the front ends.